Hey guys, we're going to talk about combinations now. We talked about permutations on the last video, and this is a slide we used where we're comparing the two. With permutations, the order matters. It's like a listing. You're ranking from first to last. Okay, but with combinations, that order does not matter. It's like a grouping. We saw with permutations that to point out specifically this time whenever I talk on the slide is that if I take the three letters A, B, and C and I rearrange those in different orders, with permutation, those six orders are viewed differently. There are six different permutations. But whenever I do this and I'm dealing with combinations, no, it does not matter. A, B, and C, they're in a group. So no matter how I rearrange them, it doesn't matter. It's still A, B, and C. So that may be another way to help you to be able to view it. But remember, permutations, positions, combinations, committee, groups. For our combination rule, again, we use N and R. N is the total possible ways or the total different items available for selection. And R is the favorable outcomes, what we're actually looking at, what we're doing. You can have the term without replacement in there in your question. Sometimes the question doesn't say that because it just should be an understood. This is going to occur without replacement. Uh, and remember, rearrangements of the same items are considered to be the same combination because it's a grouping. It is a grouping. Order does not matter. And this is my formula for combinations. Again, we're just using N and R. N will be my sample space, R, so the denominator in your basic probability ratio, and R will be my favorable outcomes, so to speak. And remember your factorial rules. Let's look at an example. Okay, so you have 6 friends, but you can only invite 2 of them over. So how many combinations of friends can you invite? So with combinations, it doesn't matter if you invite Tina before you invite Sally. Okay, that doesn't matter. So we'll go back to the stick figures, and the different colors represent your different friends. And as you look through there, this will be the different orders that you can turn around and come up with. So I have red and green, red and blue, red and yellow, red and pink, red and purple. So no matter what, I'm inviting red over, but I rotate it between the others. Well, my list is going to get smaller now because have already invited red. It doesn't matter if I invite them in first or second. And then I look at green. And these are the different combinations with green. I cannot have a green and a red because I had green and a red to start off with. And then again, it's going to get less and less until there. Because the order does not matter. Once I have a red and a green in the group, I can't have it anymore. Once I have a blue and a yellow, I can't have it anymore. So, a visual example of combinations. So let us look at an actual problem and work it. Alright, an example problem for us to work, dealing with the combination rule. So we're monitoring caribou herds for genetic dispositions, and one herd is selected to monitor a selective growth pattern in the calves. So there are 14 calves in this herd, and we're gonna look at 4 of them. What is the probability of selecting 4 calves that have this genetic disposition? So my formula, well, how about we work it this way? I'm gonna write out to make sure I reinforce this. I have my favorable outcomes. Over my total possible outcomes. And you know, these are just words, these are just statements in which help us be able to understand what is the numerator and what is the denominator. Another way I could look at this is I could just say the number of ways A can occur, A being event A. And again, it's over the same thing, total number of possible outcomes. Okay. So what is the event that we're looking at? Well, the event that we're looking at, what A equals is, uh, we're just simply looking at four calves out of the 14 will have the genetic disposition. So that way we have a better understanding. Okay, this is what we're looking at and this is what we're dealing with. This is my formula. And I know that N equals 14 and R equals 4. 14 is my sample space. There are 14 calves in there, and 4 of them are what I want to select. So I simply have 14 factorial over 14 minus 4 factorial times 4 factorial. With your factorials, you do not have to, it's like parentheses almost, you don't have to put a multiplication symbol in between there. And with this, what I have is 14 factorial over, and you just do the math here, 10 factorial, 4 factorial. Will my calculator show up for you guys? It's horrible trying to do the lighting, so you're going to pretend that you can see everything I'm typing in. I have 14 factorial divided by 10 factorial times 4 factorial, and I end up with 1001. This is the number of different ways to select the calves. So number of different ways to select the calves. What this actually is, this is my denominator. All of this is my denominator in my combination. Okay. So what I know is that I'm going to have something like this. And what I got to be able to figure out is that, and really what that is the number of ways A can occur. And this is it. I will not say with your homework problems, it's almost always going to be a 1 that you're going to have. But to understand why is that for that numerator, what I'm looking at is the number of different ways A can occur. And this is the simplicity of it. This is what you would just view as your favorable outcomes. And it is very simple. We actually use the combination rule for it. I have 4 calves and I'm selecting 4. These are the 4 favorable ways, and this is R. And I'm selecting a group of 4. So really what this turns into is 4 this is just the math behind how I get a numerator of 1. That is my numerator. That is my combination. That is my probability of selecting 4 calves displaying the genetic disposition from the 14 calves that are in the herd. Okay, guys, with these problems, As long as you have the formula and you identify N and you identify R, plugging it in is really no issue. Your answers in your homework problems will either simply be to type in the answer as given, or if it asks for a probability, it will be placed in the denominator with 99% certainty that it is a 1 in the numerator. Please watch your publisher's videos. Critically think and reason through your homework problems. Good luck with your homework in this section.